Okay, let's talk about slope. Slope. And let's talk about percent grade. Okay. Slope, percent grade. Now they're both known as gradients. Slopes are used, the calculation for slopes are used when, like on the side of a highway, when it's I will use the word drastic, but slopes can be, let's go down here. Oh, no, let's just make one right here. These are a foot, so that's 1, 2, 3, 4, 5 feet, and let's say, well, let's just say 1, 2, 3, 4, 5 this way. Now I'm going to freehand this. So if this is 5 feet, let's say, and this is 5 feet, let's say, you could say the slope ratio here is 5 to 5, but we wouldn't do that, right? We would say something like 1 to 1. There's no sense in having 5 to 5. Now those are actual dimensions, but we're going to express it in its lowest I want to call it denominator, but in a way that's kind of what it is, because we divide both sides by 5 to get it down. Now let's do another one. Let's see, what are we going to do? I want to do 6. Let's wait. I want to do 9. 1, 2, I'm sorry, not 9. I want to do, let's say we got a slope that's 6 down. 1, 2, 3, 4, 5, 6. And let's say that its vertical distance is 6, and horizontal is 1, 2, 3, 4. Now you can tell by looking that's a pretty steep slope, right? And this is 4. Now then, if it's 6 to 4, let's see, what can we do with that? Well, if we divide 6 by 4, we get divided by 4 equals 1.5. So what's the slope ratio here? These colons is like a ratio expression, 1.5 to 1, because we divided 6 by 4 and 4x4. So we got 1.5 when we did that, and when we did that, we got that. Now, this is an effort for you to understand slope, and you know, I like to get really basic on this. So a slope is a slope is a slope. Yeah. Now remember, this is jumping out a little bit. When we look at this, what's this called? I'm looking at what? If this becomes a slope in real life, it's not really going to just look like that. It's going to be three-dimensional. Right? It's going to have an x-axis, it's going to have a y-axis, and it's going to have a depth to it, because the slope will continue unless, you know, the highway may be out here and this slope is coming down to the ditch, up to the center line, and over to the other side of the road. So that's why we need to learn how to calculate slope ratio, and we will get into that in depth in just a moment. Now, if I know, let's say I know the vertical and the horizontal distance. Let's say I know the vertical and the horizontal distance of a slope. So there is a formula for ratio, and I'm going to get to this fella here in a minute. But the formula for slope ratio is this. I'm going to write it like ratio that slope ratio equals the horizontal distance. Yeah, I'm still on the camera. Equals the horizontal distance divided by the vertical distance. Write these things down. These will be important. I'm going to give you some stuff here in a minute. So let's go back to this one we were playing with before that turns out to be a 1. I said a 1.5 to 1. So what did I do here? Let's just drop down and let's substitute the horizontal distance, right? Can we do that? That's the vertical. That's the horizontal. This is going to be interesting. I wish I'd have done it the other way. 6 and 4. Let's just see what we get. This may throw us into the percent deal, but I'm going to do that. I'm going to do it right quick and see. I don't want to get off track here. I don't like the way this is working out. I want you to not forget this. This right here is what this is about. Now, the other guy, percent grade, I'm not forgetting this percent grade, but right now I just want to focus between the difference in slope ratio and percent grade. So percent grade is similar to this, and it's used in the same thing, but it's used in gradients that aren't extreme like this. It's used in more or less subtle falls, like 1% fall, like when you put in a septic line from your house to your septic tank. Probably 1% is a good fall, because if the water and sewage comes out too fast, it won't clean itself out. It'll form sediment, like in a river, on the bottom of the pipe, the inside bottom of the pipe, which by the way is the invert, which by the way is the flow line of it. So we want a subtle thing, so the water will soak as well as wash the flow line there. So we got 1%. Now, percent grade it has a formula also. It's the invert of ratio. So that would mean, the invert means turn something upside down. Okay. So the formula for this is going to be vertical divided by horizontal. Okay. Now, I'm going to show you something else. We're leading up to something. Calculating. I think the title of this thing is calculating percent slope and, percent grade and slope ratio. There's a lot of real smart people that can manipulate figures in their mind. I'm not one of them. So I find things like this. Let's see. Let's call this circle percent grade. And let's call this circle slope ratio. Okay. Remember, slope ratio is horizontal divided by vertical, and percent grade is vertical divided by horizontal distance. And when I say vertical, I mean this horizontal, vertical. That's what I mean. And your slope is going to not be as drastic as that first one. I don't know what, that 6, 4 to 1 turns out 1.5. That's a legitimate slope, and 1.5 is used a lot of times steep like that when you're in rocky areas. The steeper the slope, the less right of way you have to purchase to build your highway through somebody's property. Think about that for a while. The deeper you go, the further out. There's a relationship here. Go deep, you have a further horizontal. And if you got a highway going through here, you got a right of way, and the deeper you have to cut, the more right of way you have to buy. So there's some consideration when you design a road. All right, here we go. Here's my artistic talent. I think maybe you may have to come across. I love that. And maybe one of the modules already, maybe not. It's in one of the quizzes. By the way, I'm kind of running behind, so I'm not letting you into a couple of quizzes yet, or assignments, because I want to really doctor them up a little bit. So this right here is going to tell you how to deal with this. One of the things that you run into is when you have, let's say when you have, how can I put this? 3 variables. So with percent grade, I'm going to put percent grade right here. That's one variable. Okay, since I said slope is horizontal over vertical, see that divisor? I'm going to put vertical right here. And I'm going to put horizontal in this little quadrant right here. Now, there's nothing special about these quadrants, but there is about these functions. That's what they're called. Okay, so let's say we have a slope that has a, and we're looking per percent grade, that has a vertical distance of, we're looking for percent grade, we don't know that, but it has a vertical distance of, let's make it easy on me, 5 feet. That would be a depth of it, and it has a horizontal distance of 10 feet. Now, we know the vertical, right, is 5, so we put 5 here, so we have a number. We know the horizontal is 10 feet, so we put 10 here. Okay? Now then, this is our X factor. What is this? You know, you got a formula here, but you know, you got 3 variables you're dealing with. In algebra, if you have to cross over, let's say, I'm just going to throw this out here. If you're going to have to, if you're looking for h, you got to move h over here and 20 over here. When you cross that equal sign in algebra, you have to change its function. It'll go from a divisor to a multiplier. I can't remember all that stuff. This does that for me. This guy here does that for me. So look in here, 5 for the vertical, 10 feet for the horizontal. What's the percentage? What does this tell you? The only thing left to do is take that 5 and divide it by 10. That's where'd it go? %. See, that's a 50% is a, and a slope would be a 2 to 1, and I'll get to that later. But do you see what I did? Okay, that's good for that. Slope ratio, let's say you have a horizontal, I got that in a little low. Let's say you have a horizontal of, let's use these, 10, and a vertical of 5. So up here we got this is kind of working out pretty cool. So let's draw this line across, put a function sign, keep going so we can build a quadrant. We need another dividing sign here, and we're going all the way. This comes down, put a multiplication function in there, and then we take our values, horizontal divided by vertical. So the horizontal has to go up here and the vertical down here. So the horizontal in this case equals 10 and the vertical in this case equals 5. What does that tell us? 10 divided by 5 equals 2. That equals 2. So we have a 2 to 1 slope. Okay, this is what we're about to get started doing, and this is going to be a lot of repetition for you, but I highly recommend that in all of your spare time that you have, that you practice this. And I also highly recommend that you stick with this circle instead of moving these values or variables, they're called, across that equal sign, because every time you do that, When you have three variables and you only want one, if you're looking for vertical in this case, what are you going to have to do? You're going to have to get these values on this side of the equal sign. So you'd have to move them across there. This will do that for you. Okay, I don't want to hammer too hard on this. This is just an eye opener. Now, what's the next sheet? This is your, I don't know if I might be able to get this in your, this, I'm making a video right now, so this is for practice. So practice exercise for slope ratio and percent grade calculations. Your quiz in module or week 2 is going to be about this kind of stuff. Some questions are going to give you values for and ask for slope ratio. Some are going to ask for percent grade. So let's do 1, 2, 3, or 4. I don't want a 2-hour-long video. I want to make sure I get some maybe different, not so easy, like 2 to 1s, etc., etc. 1.5 to 1's a common one that you're going to run up to, and then there'll be more. But I want to do some of these. So when we got here first, A, that's not the, why it's A, it's a sentence. A 2 to 1 slope has a vertical dimension of 4. What is the horizontal distance? Now, you could look over here and do that pretty quick, but let's just go through it. Repetition strengthens, and this is the way I've done it before. I just draw me a circle on this practice, and the writing gets a little small, but you can see what I'm doing. Then the multiplier, then the line, and let's see what we got. It has a vertical dimension of 4. A slope ratio has a vertical dimension of 4. So we're going to put it here, and that's 4. What is the horizontal dimension? How are we going to find that? So it's a 2 to 1 slope, so we know the slope is 2, right? Because it's 2 to 1. Now, everything that you'll come into contact with for now is going to be something to 1. It may be 3/4 to 1, but it's going to be something to 1. That doesn't mean that you'll be presented something that says 6 to 4 like we had a while ago, which is the same as 1.5 to 1. We will get more familiar with that as we go. So what is the horizontal distance? Well, there's the multiplier, there's the vertical, there's the slope. So 4 times 2 equals, what is the horizontal distance? 8 feet. Look at this one. Let's draw a little circle. And there's a circle. Go ahead and go through these motions. I don't care if you did this in your head, but for now I'm just doing it to make sure we're good. So we know that we got a slope, so we know that the slope ratio equals horizontal divided by vertical. We went over that. So the horizontal goes up here, the vertical goes down here. So the vertical dimension of a 1.5 to 1 slope, well, there's a excuse me, there's a where am I? Oh, it says it's 1.5 slope, 1.5 to 1 slope. So let's put that down here where we put our other slope ratio, and I'm just going to go 1. Look at that. We don't do deal in halves. We deal in verticals. I mean in decimals when we're doing math with it. So it's a 1.5. That's the same as a 1.5 to 1 slope. And the vertical dimension is 12, so it goes over here. This is getting crowded. Sorry about that. So what does this tell us to do? Well, it tells us to multiply 1.5 times 12. 1.5 times 12 equals 18. So the horizontal distance, 18 feet. There you go. Here's let's see, vertical of 1.5. Oh, okay, here we go. Let's do 5. It's still a slope. If you've got this and you want to go take care of business or something, that's up to you. But I'm going to post the video. So I want to just draw a couple of slope examples, and then I'll do a couple of percent grade examples. No magic here. The little divisor, and then just extending the quadrant border, and then another dividing sign, and then down a little bit, multiply, down a little bit. What does it say? We got a slope, so it's going to go over here, and it tells us it's a 2 to 1. It's a 1.5 to 1 slope. It tells us right here. So let's go ahead and put that over here, 1.5. Now, the vertical distance is 2 feet. Telling us right there. So this is vertical because of the formula. It goes down here under the horizontal. So we're going to put horizontal. Then the horizontal, that's what we're looking for. So the vertical distance is 2. The ratio is 1.5. The vertical distance is 2. 1.5 times 2 equals. So the horizontal is 3. 3 feet. Okay. I'm not going to do all these. I want to go a little bit further with you on this. Got a lot of slopes. Let's start with a simple 1% grade. These are down toward the bottom. I think I can get them on there. Okay, this is 13 we're on right here. It says a surface street has a 1% rise in elevation from station 2100, 21 plus 00, to station 22 plus 00. What is the change in elevation? Okay, we got to go back to percent grade. What's it? I think it's pretty consistent. It's vertical over horizontal. It's okay. Okay, let's make our little circle. What is the change in elevation? Okay, to find the change in elevation of a 1% rise over, this is your distance, isn't it? Right? Do you know anything about stations? Hope so. I don't know if you got them too much in the certificate, but station numbers, this is survey speak, and this is the way they do measure the length or the width or the distance in a, whether it be a flat work like a grade plan or a highway, you know, for 200 miles. They measure every 100 feet. That's typical, and this is the way they record it. Sometimes there's a 2100 point so many feet, and that may be where an underground storm sewer goes under the road, you know, things like that. Maybe there'll be some more about station numbers, but that's not why we're here today. But we do have to know what the horizontal distance is, or we need to. We need to know more than what we got, I think. So here's our circle. Here's our multiplier, and here's our formula. Percent grade equals vertical divided by horizontal. So the vertical is going to go on top of our circle here. Do we know that? No. That's what we're looking for. When they say what is the rise, that's the vertical. That's the up and downness of it all. The horizontal, which this will give us, is the just what it says. It's the horizontal length of that pipe. How long is that pipe? So the percent grade is right here. 1%. When we use that mathematically, we change it to a decimal. And to do that, we divide it by 100, and that will leave us with 0.01. Now that's the same as 1%. You understand that, right? Okay. So we got a vertical unknown. We can find the horizontal. Excuse me, I wrote down something and I'm not sure why. We got a vertical that's unknown. That's our problem, to find that. But the horizontal will be this distance. You can count 22 plus 00 as 2200. Same thing. It's just the way survey speak is. And then the distance would be, take the 21, subtract it. When I say something, I want to write it down. So 2100, this, and that's minus, and this, I could do the calculator, but this looks pretty easy. That's 100 feet. So we know the horizontal is what? 100 feet. 100 feet. To get the vertical, we take the percent fall expressed as a decimal, which is 0.01, and multiply it times the horizontal. And listen, you will always do that on a pipe or something like that. You're going to take the percent and multiply it by the length of whatever that ditch or pipe or whatever you're working with to find out the vertical, you know. So the further it gets, right, the deeper or the higher the vertical. If it's a ditch, you're going down. If it's a rise, you're going up. So the vertical is 100 times 0.01. I'm just going to take that to the calculator. You've already got it, but I'm going to do it. 100 times 0.01, and it's really 200s equals 2. No, see, now why do I keep writing that 2 down? I'm very sorry. Vertical distance times percent grade is 100 times 0.01. 1 foot. 100 times 1% or 100 or decimal 0.01 is 1 foot. And you'll know that when you're dealing with hundreds. I mean, like an even 100, you in the 1%, you're just going to have 100 times anything. You know, is going to give you well, not the same number, but you know how to do that. Just move the decimal point 2 places to the right and you'll have it. So if I move the decimal places to the right 0.01, it would be 1. There it is. Okay, that's percent grade. Let me do one more, and then I'm going to set you free. Common grade, 3%. All highways, all roads should have a cross section fall from the center line to the hinge point and into the ditch. Why? For drainage. You're going to watch a video, and one of the questions I have over that video is what is the first thing or most important thing that needs to be controlled in a site preparation operation, like when you're going to build a subdivision or something. Water. You got to make sure it's not going to stand in somebody's yard. You know that it's storms come. You're going to have storm water piping put in and everything, and then all that water is going to go to what's known as a basin. That basin may be the public stormwater system. It may be a pond that they build there in the subdivision for aesthetics, as well as something to hold the runoff water. Okay, so let's use a 3% grade. There is a, let's see, do we have up? Yes, we're on number 15. There's a 3% grade from station 1234 plus 75 to station 1235 plus 65. We might as well get that out of the way. So we're going to need a horizontal in there, because what is the change in elevation? That's the vertical. So let's just take this number right here. It's the small, this is the smaller. Let's put 1234 plus 75 right here, and we're going to subtract that with the calculator. 1, 2. I didn't want that plus in there. Ignore that. It's easier not to fool with that once you know what it's for. When you're doing the math thing, you can just get rid of that plus. And this would be 1234.75 or 12,300 and no, is that right? 12,475. 123,475. Anyway, this is plus 65, so we just put it out there as 65. Now let's subtract 1235.65 minus 1234. Why do I have that? Okay. You already know what I'm doing. I apologize a little bit. I don't think I really changed anything. So I'm going to take 1235.65 and I'm going to subtract from it 1234.75. 90 feet. You can do that in your head if you want. So 90 feet, what's that? That's the horizontal. That's the horizontal. Let's draw a circle. Tightening it up a little bit. It's just to show the quadrant, the division, and then we come down with the multiplier. Come on down. We have our 3 quadrants. What do we have? We have a 3%, so we know what that is. So that's 0.0 3 right there. And let's see, what is the, we have horizontal at the top because we're dealing with the percent. No, we don't. We have vertical at the top. Am I right? No, I am not right. The vertical, that's what, is that what we're looking at? Yeah, the change in elevation is the vertical. And we have 90 feet horizontal, vertical on top, horizontal, I'm with you now, on the bottom, which is 90. And here we go back to what we did before. You multiply the percent in decimal times the horizontal distance. And in this case, the vertical, that's the change in elevation, equals 2.7 feet. Now you're gonna need to know those, and when you're looking at like a cross-section of a highway, let's say that or the road, it's a 2-lane road, and let's say it's 30 feet across the thing, you know, and you need to know the elevation of the center line. You have the elevation of the hinge point where it goes to the ditch, but you need to know the elevation of the center line. Well, you take the difference between the elevation of the, let me just, this is what I'm talking about. Here's a road. All roads are built similar to this. This is the cross section, a crude one, but it is. And see, here's the ditch, and here's the ditch, and the highway goes down the road. Here's the shoulder, and here's the shoulder. So the shoulders are usually the hinge point. So there goes your highway. So we need to know this elevation. If I know this elevation, and I know this is, I said it was 30 feet wide, so this is 15 feet. And we want a 2%. And elevate, let's say the elevation of this shoulder is 100 feet. And we want a 2% fall right there, right? So we got a horizontal of 100 feet. I should put this over here. Is that going to make a difference where I put it? I hear you saying, and he's slow as Christmas. Not quite. Okay. So we're dealing with percent grade, 2% to be exact. So we'll go ahead and put that over here, 0.02. Doesn't look like a 0. And what we're looking for is this vertical. That would be the difference in this elevation and this elevation. So it's going up. So we're looking for the vertical. And here's the horizontal. Horizontal is 15. The percent grade is 0.02, so that's going to make this 3/10. Do you get it? 0.02 times 15. I believe that's 3/10. 0.02 times 15 equals 0.3. So this right here, if this is 100, this is going to be elevation, desired elevation of 100.3. Now look, ladies and gentlemen, that is about all there is to it, except there's a lot of it. You know, keeping your records and making sure you're not doing like I'm doing, writing a 2 when I need to write a 1. All of those things are probably the most common mistakes. And if you have a mistake in there and you find it after you poured the asphaltic concrete down, you're in trouble, money-wise. Okay, again, you know, it's kind of an open door thing here. My phone is the best way, I think, to both either just chat about something or resolve something. And you might want to write this down. My name is Scotty Gex, and the number is 405-684-6828. All right. So there'll be more to come on this as an assignment. That's pretty mind-blowing coming up for you in Module 2 if you're not there yet. I haven't opened it yet because I hadn't really got it finished. It's a little complicated and I need to make it, and it needs clarity when you do try to work it. All right, that's enough for this video.